Hello, guys. Welcome back once again. Today, I'm not having my original mic, so the voice might be a bit distorted or not of the good quality, but still bear with me for that DNAT in Palo Alto firewall. All right. So, today, our focus will be DNAT. DNAT stands for destination NAT, right? So, we can say it as a destination NAT. Let me pin it here. Perfect. Let me write it. Or yeah, and I don't have the pen as well, right? So you have to bear with me both of the things. So NAT, you already know that is a network address translation. But this time the problem is normally whatever the NAT is happening, right? So that is just like we are having an internal user here, right? Let us suppose this is our internal user, and that is requesting an internet means the packet is traveling like this. It will hit the firewall and then it will be going to internet. So this time I have taken a net user as a machine here because of our DNAT, but actually that is our internet. So that's what we use normal, and in that case we use the source NAT. We also call it as a SNAT. But whenever any user who is in the internet, right? So let us suppose we are having a user here, this one, and this is the untrust. Untrust means this area is completely an internet. So in an internet, we are having one machine and that is trying to reach a server which is hosted by our company. So this is our company. You can treat it like this as our company. Let me take a shape here. It can be this one, right? This is your internal organization, correct? So here our web server is hosted. This is our web server. This is our web server, right? So now our this internet user will try to reach a website which is hosted on this server. So in that case, normally what we do, this user will be hitting a public IP address. So that public IP address could be like 100 dot 200 dot 200 dot 200 dot 200 or something like that one, right? We know private IP addresses and public IP addresses. So something in the public IP range he will be trying to reach. So now this user will be hitting this private IP, public IP address, or he might be using a DNS name, like he is hitting some www.abc.com. So it means that DNS lookup will be happening, means that www.abc.com is lookup with to the IP address as 200.200.200. It means that whenever we hit our abc.com, our DNS will resolve to the IP address 200.200.200. Now this user will hit 200.200.200. But because of the security reasons, uh, any of the web server or any of the DMZ server, they do not expose their IP address to the public. Why we do not do it? It might be multiple reasons. The first thing is like our any user who is trying to SSH, right? So if he is having SSH protocol enabled, or he think that we can access our server using SSH, so he will try to reach this, but the actual IP address is something like 192.168.100.10, while we have hosted it as a 200.200.200.200. This internet user, which can be a malicious user or his intentions are not good, he will not know this IP address. He will just know this 200.200.200. He will hit that IP. He will never come to know that 192.168.100.10 is the IP address of our server. So because of security reasons, we just put it like that. Problem is that if this user is hitting 200.200.200, then how the communication will happening, right? So in that case, what we do, this user, our net user, he what he does, he requests 200.200.200, right? So this is the destination here. And now this destination will be destination IP address, or let me write like this. It will be quite no, easy for you. So the destination IP is 200.200.200, and the source IP of this user could be like 40.40.40.10, right? So let me map it, whatever the example I'm having. In this example, I will be using the IP address 40.40.40.1. So let me take that so that you do not get confused. So this will be about the destination IP address, right? And this will be our source IP address. It means that this IP address will be on the machine. We can say here on the net user, or let me even write it. Or you understand, right? This 40.10 is of a net user. Now what is happening? This packet will be traveling from here to there, right? Now it will reach to the firewall. As it reaches to the firewall, what happens that its destination IP will be changed to what? 192.168.100.10, because the server is this. So we set up a rule in the Palo Alto firewall that whenever any of the user is hitting 40.40.40.1, please translate it to 192.168.100.10. Okay, and this IP address will be reaching to the server. So there are two cases. In one case, we can keep the source IP address as it is. In another case, we can change the source IP address as well, and we can keep it as 192.168.100.1. So it is totally on our configuration what we want to do. In our case, let me put it as 40.40.40.1. So what happens that whenever it reaches to the server will come to know that from where exactly the user is, or from which IP address the communication is being started. So now this conversation will reach to here because we are having the correct destination IP address. Now what will happen once the server process the request? Let us suppose we get any uh, ping to this server. Now it replies back. Once it replies back, it will reply to the 40.40.40.1. So in that case, it is aware, okay, we normally put a default here, default gateway. It will be forwarded to the Palo Alto firewall. And at the Palo Alto firewall, again, this IP address will be changed to 40.40.40.1. And then it will be, I think I have missed it. The source IP address was 10, right? And the destination IP is 40.40.40.1. Here it is written. So destination IP will be changed. Sorry, now it will be reversed, right? If the packet is going back, the destination will be this one, 40.10. This will be our destination IP, and this will be our source IP. And the source IP this time it will be this interface from where it was. It will be like reverse 40.40.40.1. So we have spoke too much in the theoretically. Let's jump to the uh, firewall and let's see what configuration we have to do. All right. So this is our Palo Alto firewall. Let me open it. And our topology is similar to earlier, right? There's no change in that. This is actual topology we are having. And here, let me just duplicate and put it here as 10. So this is the IP address as 10 here, like that. Lab has been saved. This is our, okay, that is in another tab. Here we are. So some of the things we have to do, we have to set up two things. First, we have to, let me go to the here and let me write it that what are the things we are going to do here. First, we set up a security policy to come the traffic from untrust to DMZ, right? So because this is untrust zone, the traffic is initiating from untrust and it is going to DMZ. So we'll allow the traffic from untrust to DMZ. Another thing, we configure the DNAT from 40.40.1 and yeah, from 40.40.1 to it will be 192.168.100.10. Correct. And at this time we have to uh, set the zone from untrust to untrust. Why we are putting untrust to untrust? Because our traffic is initiated from untrust zone and is just hitting the untrust zone. It is not like going beyond that one. The traffic going beyond to DMZs, that is after the translation. So that we allow from untrust to DMZ, and for the NAT, it is only from untrust to untrust. So two policies we are going to configure. So let me set up the first policy. Internet role, fine. Add the policy here. And that interface configuration, let me show you that I have already done it. So nothing to worry. Network. And these are the interfaces and IP addresses is already configured. So you already know it how to configure them. I'm just showing you. And these are the zones. Have already been created. I'm just setting up the policies. So let me allow it as like a web server, right? Web server rule so that guys from internet can reach our web server. And the source zone, I put it as from untrust, and the traffic goes to DMZ. Source address I don't want to configure, right? So all source IP addresses, or in fact, you want to specify only 40.40.40.0 network allowed, or in some cases you want only that these specific users are allowed, you can set it here. But this time I'm just putting the zone from untrace to, okay, delete, okay, any. And that's destination I'm putting as a DMZ. That from untrust to DMZ, and all applications, application default and actions should be allowed and log at the session start. So this is the first policy I have set. Another thing, we have to set up the NAT. So in case of NAT, SNAT we already have, no problem. I'm just putting for the DNAT rule. Destination NAT. Original packet will be originating from the untrust zone and it will be going to untrust, nothing else. Source address will be what? 40, or it can be like any. I don't want specifically mentioned. All source address will be allowed, and the destination could be any, not a problem, right? And in the translated packet, what I'm going to do, or let me put it as the destination address as 40.40.1. Let me delete this because why we are putting the destination address, because we want the translate 40.40.40.1 to some other address. So this is the destination address. If anyone is hitting this destination address, then please translate it to uh, dynamic IP and port. And what are you going to do? The source if you want to, right, I said that we are having the two options, that either we can change the source IP address as well, and we can change the destination IP address as well. So this time I'm changing the source and destination both. So the translated address could be, let's say, this one, and I'm putting an address. Source IP address I want 192.168.1. In fact, it was 100.1, right? I want this IP address as a source now. 192.168.100.1. 100.1. This can be the translated source. And now I want to the destination as well. So I will set up a destination for the static. Translated address will be 192.168.100.10, right? This is the IP address of the server. Let me just cross check. Yeah. So this is the IP address of the server. Perfect. Let me hit OK and let's commit it. And meanwhile, let me open my this machine, net user, and add the net user. Let me try to ping our 40.40.40.1. So now we see that it is replying back. We are getting the reply. So first, let's check that what is happening inside our firewall. So it is committed and monitor. Let's go to the session browser. It is getting any packets? No. Let me request the ping again and refresh. So finally, we get the package destination to 40.40.40.1 and source is 40.40.40.10. Let's go inside and check it. What is happening? So what is happening? It is hitting the rule web server, what we just created, right? This is a web server rule. And what is going to happen? It is hitting the NAT source. Let me take my pen if it works a bit. Oh, yeah. So it is hitting the web server rule, right? You see this here? And I don't have the pen. I'm just using my mouse pad to write it. And the NAT rule, it is hitting the DNAT. So in the DNAT, what it is doing? On the source, it is like 40.40.40.10, and it is going to traffic from 40.40. To 40.1. And once it is like in the translated, then in that case, the source is our dot 10 and destination is this one, correct? So let's check it, what is happening in the machine, right? The destination server. So basically, our destination server, this server, okay, let me clear it. So this is our destination server. This is basically an router. And why I have taken this router? Because we can just analyze the IP addresses, that what is happening. So let me debug it here. Debug IP ICMP. So it will tell that on from which IP the request is coming and to whom it is replying, so that we can exactly say that the translation is happening or not, right? We see it that it is hitting the rule, but actually at the server what is reaching. So we can get it from the debug. Now let's ping it here and check it at server. So you see that this is our server, and what it is seeing, it is seeing that 192.168.100.10, right? We are getting a request 100.10, but we are not having any request for the, means it is saying the destination as 100.1. Means that the I actually the it was requested from 40.40.10, right? This was the user here, 40.40.10, who is pinging here, correct? And now when he is pinging, the request is reaching to the from the IP address. Which IP address it reaching? I just miss it on which tab it was. Net user. Okay. Server, in fact. Yeah. So it is request from the 192.168.100.1. So now let's do another thing and do not translate the source IP address. I want the server know that from which source IP address the request is coming. That we can also do. So let's modify DNAT tool a bit. Let's modify DNAT. And this time I will not translate the source IP. I will just translate the destination. So here I'm not doing anything. I just set it as none. I'm just doing the destination address translation. Hit OK. All right. And just commit it. And now we will see that from which IP address the request is coming. Done. Good. Let me ping again. And let's check at server from which IP address it is coming. You see that the destination is 40.40.10. So now we do not doing any source address translation, and the destination is translated to this one. And if you do the packet capture at this machine here, here is somewhere, or from this machine, you will see, you will not come to know you that you know, right? You are hitting which IP address? You are hitting the 40.40.1, and but the reply is coming from 192.168.100.10. So this is the magic of the destination NAT, and we highly used in the production environment. In fact, everybody is using this one. We can also do the load balancing using this one, but that is a really advanced one. We will see it later on. All right. All right, guys. See you soon in the next session. Meanwhile, keep practicing. And if you like, then don't forget to leave any comment or like my video. All right. Thank you, guys. See you soon and speak to you.